Have you ever just stopped and wondered how you can ask an AI a question in plain English and it just gets it? I mean, how does a machine, a thing of circuits and code, actually understand the meaning of our words? Well, we're going to dive right into that because the answer is way more brilliant than you might think. Okay, so first things first, we've got to understand the fundamental barrier here. We humans, we live in a world of concepts, of ideas, and context. But computers, at their very core, they are mathematical machines. They speak one language and one language only, numbers. That creates a pretty big communication gap. So, yeah, that brings us to the central question, doesn't it? How on earth does a machine that only gets numbers, ones and zeros, possibly understand the feeling behind a word like love or the image in a phrase like a brilliant sunny day? And here is the big reveal. The simple answer? It doesn't. It's not about understanding the way you and I do. It's all about translation. The entire secret to modern AI is converting our messy, beautiful language into a format that a machine can actually work with mathematically. So how does this translation work? Well, the best way to think about it is with a really cool analogy. Just imagine a giant, multi-dimensional map, a map of meaning. And on this map, every single concept you can think of has its own specific place. Now, this location on the map, it's got a technical name, an embedding. You can think of an embedding as the AI's idea of where a concept lives in this massive meaning space. So the word king gets its own unique spot, its own specific address on the map. That's its embedding. And how do you define a location on any map? Well, with coordinates, right? Like latitude and longitude. For an AI, those coordinates are called a vector, which is really just a long list of numbers that acts as the precise address for that embedding on our map. And that's the key thing to remember. The embedding is the place, and the vector is the address that gets you there. And this right here is where the magic happens. On this map, distance is meaning. Words that mean similar things, like king and queen, are going to have vectors that place them really, really close together. But words that are totally unrelated, like king and, say, screwdriver, they're going to be miles apart. It's a brilliantly simple way for a machine to measure how related ideas are. All right, so we've got this incredible map of meaning, but, who draws it? How does a word actually get its coordinates in the first place? Well, that happens through a process we're about to break down. It's got a name, and that name is vectorization. This is the engine, the machine that takes our human language and converts it into those powerful numerical vectors that an AI can finally understand. And it's actually a pretty straightforward three-step journey. First, you feed it some text. Could be one word, could be an entire book. Second, that text goes into a specialized AI called an embedding model. You can think of this thing as the master map maker. And then third, out comes the vector, that list of numbers, the final coordinates for our map of meaning. And get this, there isn't just one map maker. There are a ton of different embedding models out there, each with its own special way of understanding language and creating these vectors. You've probably heard of some of them, like BERT, or the models from OpenAI. Each one creates a slightly different, but still incredibly powerful map of meaning. Okay, so we have a map, and we know how to put things on it. Now for the really exciting part. What can we actually do with all this? This is where the true power of AI language understanding really comes to life. Let's start with a classic example, search. The old way, keyword search, was so rigid. It could only find the exact words you typed in. But now, with semantic search, which is powered by these embeddings, we can search for the meaning itself. It's the difference between being a literalist and actually being intuitive. And this is just a perfect example. A keyword search would see these as two totally different things. But a semantic search system, it knows that on the map of meaning, how to fix a flat tire and repairing a punctured wheel are located right next to each other. They're practically neighbors. The AI understands your intent, not just your words. And this ability unlocks so much more than just better search. It powers clustering, where an AI can automatically group similar articles together just by looking at their meaning. It's also the engine behind classification, which is how a system can figure out if a customer review is positive or negative based on the overall feeling of the words, not just a list of keywords. So, as we start to wrap this up, it's really important to zoom out for a second and see the bigger picture. This isn't just some clever trick for building better search engines. No, this is something way more fundamental. When you get right down to it, This is the main takeaway. Vectorization and embeddings are how we actually give AI knowledge. By translating the messy, conceptual world of our language into the structured, mathematical world of numbers, we're laying the foundation for an AI that can work with information in a truly meaningful way. And that leaves us with a really fascinating final thought. We have created a system that can literally map the relationships between all of our concepts and ideas. So, if an AI can navigate the world of our language this effectively, what other worlds will it be able to map for us next?